Okay, good afternoon, class. My name is Ms. Delgado, and today we are going to be going over relationships between lines. We are going to be going over a total of 5 different relationships between lines, and we're going to be going ahead and showing examples using this diagram right here of a cube. Okay, so we're going to go ahead and start off with the first one, an intersection. An intersection are two lines that touch or cross. Two lines that touch or cross at exactly 1 point. So that's two lines that touch or cross at exactly 1 point. An example of that would just be any two lines that cross at one given point. Okay? An example of that on our diagram would be, for example, A and B. What line is that intersecting with? Any other line? It can be A and B and AF. AB and F intersect at one given point. So let's go ahead and write an example. It would be an example of A, B, and A, F. Okay? Our next relationship between lines is going to be parallel lines. Parallel lines are two lines. They lie on the same plane, meaning they're going to be on either this face of the cube, this face of the cube, or this face of the cube. Okay, they all have to be on the same face because they lie on the same plane. So they are going to be two lines that lie on the same plane, but never intersect. So unlike these lines, parallel lines, and you can remember that by the two L's in the middle, parallel lines, the L's, just like parallel lines, are never going to intersect. So they are never going to meet. Okay? An example of those will be, let's say here, what lines do D and G intersect with? I'm sorry, do not intersect with. Let's go ahead and see an example of this. We're going to go ahead and draw our lines that are never going to intersect with anything. And C and H. Because no matter how far we draw these lines, they are never going to intersect. So let's go ahead and write our examples. It's going to be line D and G and C and H. And let's draw our little diagram of parallel lines. Draw our arrows. And then we show that they are never going to intersect. Just like that, okay? Okay, so our next lines are going to be concurrent lines, okay? Concurrent lines are going to be 3 or more lines that share one common point, okay? So let's go ahead and write our definition. 3 or more lines that share one common point of intersection. Okay? So concurrent lines are three or more lines that share one common point of intersection. Let's go ahead and see here. Let's go ahead and use, for example, the same lines that we used up here, A and B, and A and F. Let's go ahead and highlight those. A and B, let's go ahead and circle those. And B and F. What other line also intersects with those points? It's going to be A and D, because they all share point A as an intersection. Okay, so we're going to go ahead and write our answer and draw our diagram. So we have line number 1, number 2, and number 3. We have to have 3 or more lines. 1 line, 2 lines, 3 lines that share one common point. Okay? So we have that, and let's go ahead and write our examples. We're going to use the same ones that we used up here, plus A and D. So let's go ahead, AB, AF, and A and D. Notice how they all have the A in common. A, because that's the common intersection. Okay, let's go ahead and go to our fourth type of relationship, which are perpendicular lines. Perpendicular lines are two intersecting lines that form a right angle. Who can tell me what a right angle is? I have my protractor. A right angle is an angle that measures exactly 90 degrees. I don't know if you can see it. Okay, so let's go ahead and write our definition. Two intersecting lines that form a right angle. What does a right angle mean? How many degrees is that, we said? 90 degrees. Okay? So then let's go ahead and see. Since we have a diagram of the cube, what can we automatically say? That all angles on this cube are going to measure 90 degrees. Okay? So let's go ahead and use, for example, I already drew a little angle. Let's go ahead and measure our angle. We have to measure and make sure that it measures 90 degrees. So we go ahead and measure that. And yes, we confirmed that it does measure 90 degrees. So our example are going to be line AF and FG. Okay, lines AF and FG. We can tell that they have F in common, meaning they intersect. We measured our angle, which equals 90 degrees. So we figured that one out. Okay? On to our last type of relationship, which is going to be called skew. Skew are two lines that do not intersect, so they are never going to intersect. They're going to be like parallel lines, but they never intersect because they do not lie on the same plane. Remember, the same plane means that it's one same plane. Every face on this cube is on a different plane. Therefore, we are going to have to find two lines on this diagram that do not intersect and are also not on the same plane. Okay, so let's go ahead and write our definition. Two lines that do not intersect because they do not lie on the same plane. Okay? And so let's go ahead and look at our diagram and try to find two lines that do not intersect. We use our ruler and also have to be on a different plane. So let's go ahead and keep using AF because that's the line we have been using the most. AF. All of our horizontal lines are going to be intersecting or on a different plane. Let's go ahead and see AF. We read our first line. AF. And you can see we can draw a line over AF. And we are going to go ahead and use D and C. We circle our lines. We draw that they are never going to intersect because they are on two different planes. We use D, line D, C. Okay, so here are our 5 different types of relationships between lines. Okay, and in the moment we are going to be going over some practice problems. And afterwards, I'm going to go ahead and give you some practice problems to finish here at home, and we will discuss our homework, okay? I'm going to go ahead and leave these definitions up here so you can all copy them down, and we're going to go ahead and get started in about 3 minutes with our practice problems.